All right, so here we are in 3-7. So how can I prove triangles are similar as efficiently as possible? So how many angles does it take to know two triangles are the same shape? So that's what we want to figure out here. So, and when I say same shape, I just mean similar. So postulate, well, let's just think here. If I had one angle that was the same, would I know that they're necessarily similar? Not really, right? Because I could make that other angle as much as we want. If I had two angles that were the same, they would have to be similar. So postulate 7.1 says angle-angle similarity, or AA similarity postulate. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So in this one, I would have triangle ABC is similar to triangle DEF. All right, so we know that if two angles are congruent, then the third angle has to be congruent, because all the angles in the triangle have to add up to 180. So are they similar? So here, if I find that other missing angle, I'll get 51. So that must make that one 39. So yes, they're similar by angle-angle similarity. All right, in this one, I have an isosceles triangle up here and an isosceles triangle over here. This is 68 down here, so this one has to be 68. So the other one has to be 180 minus the 268s. So it's 44. So right there, I can tell that the vertex angles are not the same. So no, they're not similar. All right. The next one. So one of the ways that we can show two triangles are similar is by angle-angle similarity. Another way we can show that there's some, also just remember back in chapter 4, we talked about proving triangles congruent. So we had side, angle, side. We had side, side, side. We had angle, angle, side, angle. And we had angle, angle, side. Okay, so this is like doing the same thing, but just for similar. All right, so we have side, angle, side similarity. So SAS, similarity. If you notice, there's that similarity symbol. So if an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. So if okay, so if the included angle and then the sides that include those angles are proportional, then the triangles are similar. All right, the side-side-side similarity postulate says if the corresponding sides of two triangles are proportional, then the triangles are similar. So here I don't have to look at any of the angles. So here's ABC, here's DEF. So if I know that AB over DE is equal to BC over EF, which is equal to AC over DF, then I know that the triangles are similar. So again, I'm just lining up the matching sides there. Okay. All right, are the triangles similar? If so, write a similarity statement and justify. So when I'm looking at this one right here, this one I don't know anything about the angle, so the only thing I can check are the sides. 6 smaller than 9, 8 smaller than 12. So 6 over 8, is that equal to 9 over 12? So I'm keeping the triangle ABC on top, triangle GEF or EFG on the bottom, okay? 6 over 8, both divisible by 2, so I get 3/4. Here, both of them are divisible by 3, so I get 3/4. So yes. If so, write a similarity statement so they are similar. So I know the triangle ABC, so here's my similarity statement, is similar to triangle EFG. I'm lining everything up. The G is the vertex angle there. And the reason is because of side, side, side similarity. That's my justification up there. On this one, I have two triangles. I have this small one right here, and then I have the big one. They share that angle right there. So I'm going to check to see if side angle, side similarity works. So in my small triangle, I would have 6, which would line up with 12 in the bigger triangle. And then I have 8, which would line up with 16. This ends up being 1/2. This ends up being 1/2. So yes. So I have triangle AWL is similar to triangle AEC. And the reason for this one is side angle, side similarity. All right, in this one, I want to prove that two triangles are similar, and I know that MP is parallel to AC. I'll just do 2 columns. Okay. There's a couple ways to do this, but if we know that we have these 2 parallel lines here, let's just think about if this is a transversal, then this and this is congruent because they're alternate interior angles. So angle, I'll just call it angle C. There's only one angle C that's inside here, so we're not going to worry about 3 letters. Angle C is congruent to angle M, but then I also know if I thought of this as the transversal, this one is congruent to this one. So parallel lines tells me that the alternate, remember I was given the parallel lines, so I know the alternate interior angles are congruent. And then 3, now I can say the 2 triangles are similar. I can say they're similar because of angle similarity. I didn't use this side at all. You could also throw in the vertical angle, but you still need one of these other pairs of angles from the parallel lines. All right, indirect measurement is the process of using proportions to find unknown measures in similar objects. So here's Darius. He wants to know how high the cliff he's going to climb. So he places a mirror on the ground and walks backwards until he can see the cliff. He knows that he has 2 right angles right here, and he's also setting it up so that these 2 angles down here are congruent. So I know that these 2 triangles are similar because of angle similarity. So I know that this 6 matches up with this 34, and I know that his height matches up with what I'm missing there. I cross multiply. We get 31.616 feet repeating, which is the same thing as 31 feet and 2 inches. Like if you just look here, if I do 187 divided by 6 minus the 31, so that number right there, if I multiply that by 12, that's my 2 inches, okay? All right, I will do a couple of these with you. We'll look at 26 and maybe the proofs. We'll see. All right, so 26. So in 26, these lines are parallel, so the corresponding angles are congruent, plus the triangles share this top angle, so I've got two pairs of angles that are all similar, congruent to each other, so the triangles are similar. So I could say 10 over, so this short side is similar, it's the same as 10 plus x in the bigger triangle. X plus 2 is the same as x plus 14 in the bigger triangle. So I'm going to multiply. So here I'd have 10x plus 140x, because I got to distribute that 10. Over here, I'm going to rewrite this. So I'm going to have x plus 2, and instead of using 10 plus x, I'm going to write it as x plus 10. So over here, x times x is x squared. So remember, we have to FOIL again. The outer is 10x, the inner is 2x, so I've got 12x. Then the last is 20. All right, so what I want to do is I want to get the x squared, like I want to have everything over here because I have a quadratic. Sometimes the x squares go away, but in this one it doesn't. Subtract 10x, so I just have plus 2. Subtract 140, so I have minus 120. And this is all equal to 0. So just like before, I did this with you in the other one, you've got to figure out, you've got to kind of unfoil it here. So what numbers can you multiply to get negative 120, but when you add them together you get 2? So if I did it this way, I would have negative 2. If I did it this way, I'll end up with the positive 2. So I'm going to have x plus 12, x minus 10. So then I'd have x plus 12 is equal to 0, x minus 10 is equal to 0. So x is negative 12, x is 10. The problem with x being negative 12 is if I plug in negative 12 here, I'd have 10 plus negative 12. So that would be like saying this side of the triangle is negative 2. That doesn't work. So the only answer is this answer right here. Okay? All right. Let's see here. All right, let's look at one of the proofs. So let's look at 28. So in 28, we got a lot of parallel lines here. And if you notice, we want to try to prove that we can multiply some of the sides together. All right, so this is what I want to try to prove. If you think about it, what probably happened here in the step before was probably we had something that looks like this. Okay, so I'd have big triangle over little triangle, big triangle over little triangle. So that's probably the step right before it. So somehow I probably want to show that these two triangles are similar to each other. And then I can say that the sides are proportional. And then once I know that the sides are proportional, then I could say that, once I show that the sides are proportional, then I'd be able to say that the triangles are similar. So I guess start off with my given. the easiest way, so if I'm given this parallel line stuff, these lines are parallel. Here's the transversal. So these angles right there are congruent because they're corresponding. These lines are parallel. Here's the transversal. These lines right here are congruent because they're corresponding. Okay, I could have done that in one step. Well, now if I have two angles congruent, then I can say the two triangles are similar. But then if I know the two triangles are similar, then I know that the sides are proportional. So I wrote it a little bit differently than I wrote it on my paper before. You could write it like that if you wanted to. But then if I cross multiply, I do that cross product, I get what I'm trying to prove, okay? Again, if you want to change it here, and I could write the CD here and the AC up here, you would see when I cross multiplied, I'd get the same thing. Again, I'm just saying that AB over CD is equal to AC over CG, okay? So it works out the same as well. All right.